Welcome to STEMz Learning Podcast, the podcast where we explore the exciting world of science, technology, engineering, and mathematics, and the people who contribute to them. I'm Deborah Davidson, and in today's episode, we're going to dive into the exciting world of Earth and planetary science with Dr. Anastasia Montgomery. Let's start with the basics. What is Earth and planetary science?
Hi, Deb. Thanks for asking that question. I love talking about this. Also, you can call me Stacey, so we don't have to be so formal
So
here.
formal, yes, Deb.
Yeah. So Earth and planetary science is the study about how Earth works, and also how other planets work too, using the kind of lessons that we learn on Earth and applying it to other planets. It's about understanding land, oceans, atmosphere, even what's happening at the center of the Earth. In this field, people ask questions like, how did the Earth and other planets form? What causes earthquakes, volcanoes, climate change? What can rocks and fossils tell us about ancient environments and what's happening on other planets like Mars or moons? So it's a very interdisciplinary field where you use subdisciplines like geology, chemistry, physics, biology to piece together the history of the Earth and other planets.
Wow. Okay. So subdisciplines, or we're talking, so it's a lot of different big topics that
Mhm.
come together under this big umbrella of planetary and earth science. That's so cool. So it's not just Earth that's the
Yes.
planet that you're studying. You're also studying other planets' effect on.
Yes.
Wow, that's so cool. What drew you to Earth and planetary science? So what made you, this is what your PhD is in.
Yes. Yes,
Yes.
it is.
What drew you to that topic?
What drew me to Earth and planetary sciences was honestly like they were kind of two paths to it. So first, I feel like my entire life I've heard about climate change. I remember I was in elementary school when An Inconvenient Truth came out, and looking at that graph of atmospheric carbon dioxide, like this red line that was just kind of like stagnant and then goes up like a huge amount, just a ridiculous amount, beyond exponential growth. That really kind of spooked me and kind of set an intention for my personal like life, thinking about like I became a vegetarian as a child
Mm.
in response to that. But then also like thinking about picking out a career, I really was interested in going into a field that actually tried to help address these kinds of like social problems. And I really felt since a child that climate change was going to be a big problem, and I wanted to do something in that effect.
Well, and
Um,
ding, 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 you were right. It
I
is still,
know.
we're the
Wow.
same age. It is still a big problem. And for our listeners, the rising carbon dioxide. What is carbon dioxide?
So carbon dioxide, it's a molecule. So that means like it's a chemical that is in our air. It's odorless. You can't see it. And it only actually makes up less than 1% of our entire atmosphere. But what it does is it traps heat on our planet. So
Mm.
as a result, when we've been increasing this CO2, we've been actually trapping more heat on our planet, causing all of these other weird knock-on effects like storms, droughts even. So yeah, it's a huge problem.
Right. So the changing kind of temperatures or changing weather, general
Mhm.
climate conditions, are attributed to a wide variety of things, right? Like lots of different things. One of them is the rising levels of carbon dioxide in the atmosphere or the air, right?
Yeah. So that's honestly what's causing all of this. By rising CO2, we're ending up trapping all this heat. And then anything else that comes from climate change, whether we look at ice caps or ocean circulation, acidification. There's all these very interesting resulting effects in our planet just because we've kind of shifted this energy balance. So
Right,
yeah.
kind of the butterfly effect, like so the rising carbon dioxide happens. And what
Mhm.
is causing the rising carbon dioxide? Is there an easy answer for that, or kind of can you speak more to that?
Yeah. The answer is, I would say, pretty simple. We as humans, after the Industrial Revolution, have really began to burn fossil fuels at an increasing massive pace. So fossil fuels are things like gasoline or coal, and these chemical components have been in like the earth. It's been in a rock and it's been stuck there for millions of years. We're bringing that back up and putting those chemicals into the atmosphere. So we're now just disbalancing this like mass and energy balance by doing that. And yeah, fossil fuels is just basically how the world works. You drive your car, you turn on your lights. All of this is thanks to like electricity and
Right.
power plants and yeah, gas.
Right. And would you say that there's kind of this common theme of balance, right? Like I heard you say that the fossil fuels that we use, what we take from the earth
Mhm.
kind of creates a disbalance. And then that sets off kind of the effects or what the effects being what we call climate change is the disruption to the kind of balance that we have in the earth. And if you take too much,
Yeah.
earth has to compensate or adjust itself in ways that can make humans uncomfortable.
Yeah, and I think another really cool aspect of Earth and planetary sciences is that people who study this field look at all the different ways that Earth has been knocked out of balance before. Like what we're experiencing right now is very much attributable to anthropogenic burning of fossil fuels.
Anthropogenic being human caused, right?
Human caused, yeah. So human caused climate change is definitely what we're experiencing right now, but we can see in the geologic record, so looking back at rocks, looking at the chemical composition of these rocks.
Right. And
uh,
that's so basically your earth historians kind of.
yeah,
Yeah.
using earth historians, and you're like reading the rocks, and what we can see is these other times in earth's history where it gets knocked out of balance. So we can use things like, oh, just like the arrangement of the planet relative to the sun. It's
Mhm.
called the Milankovitch cycles. That actually controls like how much ice we are experiencing on this planet. Like we in Earth's history have not always had ice caps. Thinking about Antarctica, thinking about the
Wow.
Arctic. Yeah, it's been melted before. There has been tropical life on our poles before because of where the Earth
Wow.
was located in the
Mhm.
solar system. And we have been able to look into like the fossil record and identify that, okay, we have seen like these really tropical conditions in other parts of the planet, but it
Mhm.
was also due to like this extraplanetary force, as opposed to what we're experiencing right now, which we can attribute to burning fossil fuels.
Right. And correct me if I'm wrong, the aspect of climate change that creates what we would call a problem is the short period of time that these changes are happening, not the changes itself. Because as you said, as Earth historians, you see plenty of changes over the years with the data that you collect. And the story that it tells. However, that story takes place over millions of years, where the changes that we're seeing are taking place over decades, tens of years, lifetimes. The weather changes that I even see as a kid, we used to get lots of snow when we went skiing in Massachusetts. And around the time I turned, 18, 19, we no longer got snow around Thanksgiving time. In fact, last Thanksgiving we went kayaking. It was that warm. Yeah. And as a kid, growing up, being 6 or 7, having, 4 feet of snow to being able to go kayaking, that kind of weather change in a single area over less than 10-year period that's the problem.
Yeah, yeah,
Okay.
yeah. So like, yeah, and you bring up the point of like, what is weather, what is climate?
Mhm.
And typically I think of this analogy of weather is you look in your closet and you grab your raincoat because it's raining today. Climate is what kind of coats do you have in your closet? Are they
Mhm.
winter jackets? Are they rain jackets? All that kind of information. So, what you're describing right now is just basically this changing baseline. You have a closet filled with all these fluffy winter coats, and you're finding increasingly you do not need those jackets. That
Mhm.
area, that climate, it's shifting. So yeah, and the fact that it's happened relatively quickly, it's really difficult to identify other times in geologic history that has experienced such a rapid change in climate. There certainly have been these kind of like really dramatic events, like when an asteroid hits the Earth and then completely changes the atmospheric composition.
Right. Bye bye dinosaurs.
Exactly. Yeah, like there are these very dramatic extinction events that we look at. But yeah, it's really difficult to look at beyond when life first began to arrive on Earth and actually change our atmospheric composition, it's really hard to look at the way that life has so dramatically changed our atmosphere so quickly. Because even just like when we went from all this like water-based planet and then used microbes to add oxygen to our atmosphere, that was a process that happened over millions of years in early Earth history. And as you're saying, we're looking at something that's happened over the course of maybe 150 years.
Yeah, right. No, and that brings me to my next question, the kind of real world impact of being curious about these kinds of things and studying them and becoming an earth scientist as a career path.
Mhm.
What's the kind of data that you guys work with? And so data being the numbers that you collect, data is not just numbers, it can be, words and information. It's any information, right? Data being information. What kinds of information are Earth and planetary scientists working with? And what does that information tell us?
Yes, yeah. So I think, yeah, as I said earlier, the field of Earth and planetary sciences is so broad. Everybody's using everything, both stories and information from communities to describe what's happening, rocks as an example. And then my specialty has looked at the atmosphere. So I'm looking at like the
So could
gaseous.
you describe the atmosphere for those of us that might be confused about like what is the atmosphere?
Yeah, the atmosphere is the air that we are breathing. There are, yeah, right now we are sitting in the troposphere, which is the part of the atmosphere that is closest to the surface. It's the part
Uh,
that we're living in, and it actually has most of the mass of the atmosphere is in the troposphere.
when
And
we
that's
walk outside in our city and where we live, um, that's just the slice of pie that is the atmosphere, troposphere.
correct.
Okay.
Yep, yep. And so the atmosphere, it's layered. It has to do with pressure. It has to do with chemistry. But yeah, we live and breathe in this atmosphere. And my specific specialty has been focusing on the chemicals that are in the atmosphere. So I have always looked at, for example, health hazardous chemicals. So these are the kind of pollution in the air that causes harm to humans.
Okay. And are
Yeah.
there good chemicals?
Yeah, of course. We need to breathe oxygen. That's a great
Because when
chemical.
I hear chemicals, I think, oh, bad. But
Yeah.
so
Mhm.
you study the bad ones, but what are the good ones?
Yeah. Well, I think there is good and bad. It just depends on like who you're talking to, I would actually say.
Is it the amount
Chemicals,
that makes it good or bad?
certainly. I think too much of anything is bad. You can have too much oxygen, I think. But for example, like it actually is good that we have a little bit of carbon dioxide in our atmosphere. That helps.
Okay.
Yeah, the fact that we do have a chemical composition on our atmosphere, and the concept of a greenhouse effect. So the fact that we have this layer of atmosphere and it traps heat because of all the chemicals that are on our surface. That's
Right. Keep
actually,
us from having an ice planet.
yeah, it
Mm.
prevents us from having an ice planet. So actually, the fact that we do have chemicals in our atmosphere is really useful because if you look at something like the moon has no atmosphere.
Okay.
And all you can see is just, people bouncing around and it's very cold. And we as humans need to wear spacesuits in order to survive in that place. The
Right.
fact that yeah,
Because it doesn't have atmosphere, does that mean we can't breathe on the moon?
no, we
Okay.
cannot breathe on the moon. We need to
If
bring
it
our
had an atmosphere, would we be able to breathe, or would it need to look more, is it more complicated than that?
Yeah, it is more complicated than that. Like, for example, if you look at like Venus or Mercury, these planets that are right next to the sun, they have really thick atmospheres and they're filled with like sulfur gas. That would not be helpful for us. And also, they're really dense and heavy, so we might get squished.
Oh,
The
wow.
pressure of the atmosphere is also important. We
Mhm.
as humans have adapted to life on Earth. So that's why it's like, wow, Earth is perfect for us, but also every single life form on this planet has adapted to life on this planet specifically. So, yeah, the fact that we have a gas, like we have chemicals in our atmosphere, not inherently bad. In fact, most of our air that we're breathing right here in this troposphere is 78% nitrogen gas.
Oh,
I
so
know.
that's our atmosphere is made of mostly the element nitrogen.
Yes. Yeah. So if you even think about it, like it's inert, it's not doing anything to us. We are breathing it as we breathe in, but what our lungs are reacting to and like absorbing into our bloodstream is the oxygen that's in the air. So yeah, if you have too much of any of these chemicals, things go awry.
Mhm.
And the Earth's atmospheric composition, so the way that the Earth has been, that this atmosphere has been formed throughout time, it actually has changed depending on what kind of life is available. We've always influenced like the things that are happening on the surface of the Earth, the things that are happening in the interior of the Earth has affected what's happening in our atmosphere as well. But yeah, right now, we really like the atmosphere as it is currently. And that's why we need space suits. And it's a lot of support to try to recreate this atmosphere somewhere else.
And you talked about studying kind of the harmful chemicals that can be in the air. Does that change from place to place? Are you looking at the whole of the Earth's atmosphere, or are you looking at certain cities or certain places?
Mhm.
Do certain places have bad air, quote unquote, or in some places have good air?
Yes, yes. And actually, uh, I should probably finish the original question, which you asked me. You asked me what kind of data do I use and what
Yeah.
kind of tools do I use. So because I'm focusing on the atmosphere, because I'm also focusing on a very, very tiny portion of the atmosphere, 78% of the atmosphere is nitrogen, 20 some percent is oxygen, and then 1% is the rest of the chemical components, including pollutants, like things that will harm people's health, including greenhouse gases like CO2, which doesn't necessarily harm health, but it does warm the planet. So what I use are these really, really impressive instruments that manage to slice and investigate less than 1% of the atmosphere. Like you can tell, like you can't see anything in the room. So these are really tiny, tiny chemicals that must be caught. So you can use sensors to find that. You can use satellites to find that, and you can also use what
The
you understand.
satellites that are floating in space
Yes, we
collect
can.
that information.
Yeah, so like basically by taking pictures of the atmosphere and using special kind of lenses on these satellites, you can actually investigate what kind of chemicals are in your finder right there.
Wow.
Yeah. And then you can also use modeling. So, what you understand about chemistry, what you understand about physics, and put those two things together and actually recreate an atmosphere that's just a little bit simplified.
That's so cool. Do
Mhm.
you have a favorite part about what you study?
Do I have
Or a favorite, like a fun, your most fun earth science fact?
Oh, yes, I do. I do. I was actually, this was something that I realized. I'm like, oh, there's so many good earth science facts. And it's really hard to pick. But I think one that I think about a lot is that we're familiar that there are magnetic poles on Earth, right?
Mm. And the poles being what you talked about, the ice, like the north and the south.
Yes, so there's magnetism on Earth. Like the fact that there's magnetism actually comes from the fact that at the center of our Earth, we have a lot of magnetic material, like it's lead. And
Like a
this is
magnet,
actually,
like what you put on your fridge, like a magnet.
yes, yes,
Oh, okay.
magnet. We have magnet at the center of our planet. And because of that, we have these magnetic poles. This is how compasses actually work. But because that core is actually like this liquid metal, sometimes the poles switch.
What do you
So
mean?
so like what we would consider north
Uh-huh.
when we have our compass, it actually switches. And sometimes because again, this core is at the very center, it's got so much pressure, so much heat that this rock is actually ended up getting like liquidy. Um, there can be multiple poles on the earth. Yeah.
My
So
goodness.
yeah, magnetic north isn't necessarily the poles of the planet. Magnetic north is kind of dictated by this uh, metallic material in the center of the Earth. Granted, the last time the pole switched was like hundreds of thousands of years ago.
I was
So
gonna say what would happen, because I guess it wouldn't really matter 100,000 years ago when people didn't have technology.
yeah,
But now, if the poles switched, what would happen to computers and phones and satellites?
exactly. Yeah, or like the fact that like the the magnetic north can wander. Like you're like, wow, that really seems like that's kind of a hazard.
Wait,
And
if
it's
someone gets lost in the woods and they're looking at a compass and they're supposed to be, is that why people use the stars? Is that a
That's
more
why people,
reliable?
yeah, people have always used the stars to navigate. Yeah, like you can use compasses, but they can be actually also interfered with by other local magnetic disturbances.
Ah,
But
so
yeah,
sometimes it pays to use the kind of older, sort of more primitive technologies, more
yeah,
accurate.
but it's actually kind of interesting because now if you think about like how are we figuring out where to get places, GPS is also like we're using space in order to figure out where we're going.
Right. And
So
it's not always accurate. Just today I walked outside and my phone that's supposed to be accurate
mhm.
pointed one direction, said that was the right way, that was north, and it was completely behind me.
Oh my God. I
Yeah.
hate when that happens. But yeah, that's an example of how like your phone compass is being influenced by all the other signals that it's picking up on in the environment. So yeah, if only you could see the stars, which you're not going to see in New York City. We're not going to figure out
The
where
light
we're going.
pollution. Yeah. It's worth going out to see because they're beautiful. But if you get lost in the woods, yeah,
Yeah.
maybe put your phone away if it saves
Yeah.
battery and look up.
And I mean, I do really think it's super easy like to look at where the sun is in the sky, east and
What is
west,
that? What would that information would that tell you?
where east and west is going. So if it's
Okay.
sunrise,
Right, the sun rises from which direction?
the east, I
The
think.
east and then sets in the west?
Yeah.
Yeah, yeah.
Let's quick fact check that right.
Yeah, yeah, quick fact check. Asterisks on that.
Right.
So any kids that are interested, they're like, this stuff is so cool. I could really see myself doing that, when I'm an adult. What would you recommend they do starting now, to get them better acquainted, with the field and help set them up for success later in their life?
Yeah, of course. I think what is really interesting about STEM and in particular Earth and planetary sciences is because it's so interdisciplinary, where you can come to this field with a variety of interests, whether it be chemistry or physics or even history, like how have people and climate interacted? That's a climate field of study. Um, I think what you should do is stay in school,
Hmm.
uh, foster an appreciation for school. Where I got today is that I did do a PhD, which means that not only did I go to a 4-year university program, but I went on to do 5 more years to get my doctorate degree. Uh, so I think you should figure out if that sounds like something you would enjoy. I really did enjoy it because I love learning and I love being able to answer questions, and
Yeah.
my job is to figure out how things work. So if you're the kind of person that always says like, "Why is it that way?" And you endlessly pepper your parents with questions, why?" That's me as an adult.
You might want to be an expert in a field. Yeah.
Yeah, and kind of like in Earth and planetary science, it's an expert in the field of everything. You're using all of the scientific disciplines in order to describe what's happening just around you. So you can look at it, or you can also like be so in the weeds that you're actually thinking about molecules, so you're not even really looking at anything. So yeah, keep paying attention at what you're good at in school. You're going to have to figure out how to write and talk. So make sure that you also grow those skills as well. But yeah, just enjoy school. And I think regardless, every job is a climate job.
Mm.
So I think you should pursue a field that helps us with this climate change problem. No matter what you're doing, every job does touch on, society. So therefore, I think every job is a climate job. So why not come?
Yeah, I mean, I agree. I think everything, I say all the time, everything is science,
Yeah.
Everything is science because science is curiosity. It's a way of looking at the world. Um, and yeah, and like you said, it's nice that planetary and earth sciences seems to be this kind of umbrella that even if you might say, well, that's not, necessarily speaking or writing isn't my strong suit, but math is. There's
Mhm.
a huge place for that. There's a, you could argue any skill has a place in earth science.
Exactly.
Yeah.
Yeah. Like it's just about like applying what you learn throughout school, applying what you find you have interest and passion in, and bringing it to the field of earth science.
Right.
We
It's a lens at looking through the world. Just like
exactly.
our last episode was on environmental science. And I
Mhm.
said, in that episode, the conservation and environmental science, it's everything. It's being curious about the world. It's opening your door and stepping outside and be like and asking yourself, how does this work?
Yep.
And why does it work this way? And
Hmm.
it's cool because we're at a point in history where we have a lot of answers, but also still have this huge mystery of so many questions still for you listening to figure out.
Yep.
Well, and I wish I could talk to you all day, Stacey. This has been so nice.
Mhm.
I want to say a reminder to check out our STEMz Learning YouTube channel for additional episodes and stemslearning.org if you want to teach yourself some STEM topics. We offer mini courses to elementary and middle school students, and they're available every month. Thank you so much, Stacey, for joining me today. I hope that you have a wonderful rest of your day and good luck in your search for, climate answers. And I hope that you are part of the solution and that we can build a better tomorrow for all of us.
Mhm.
Thank you so much.
Thanks, Deb.
Yeah.